Very good afternoon. So in our previous lab, what we have done is all the arithmetic operations and how to create the matrix, how to create the vector, that what we did in our last lab, right? Now what we are doing today is we'll see again few more operations related to the matrix, and then we will start with the control structure, right? This is what we are going to do today. So, do you remember from where we went the session? Do you remember this? Yes or no? How to print in reverse? This is what we have done at the last. Yes, right? So after that, again, few more example how to delete a row or column. So suppose I'm having any of the matrix here, right? That's some value I'm giving. And here I want to delete this third row, okay, and all the columns. So what I need to write? A of 3, third row, and all the columns. For that it's column. And that equals to, I need to set it to null vector. So that will be deleted. So now you can see here the third row has been deleted. Same way, if I wish to delete this last column, then what I need to write? Yes, if it is the last column, then what I need to write here is anyone who can write here? No one? Okay. A of for all the rows and third column. Yes, correct. Equals to null. No, Sagni, I just want to delete the last column. Last column. So what I need to write? A of for all the rows, I want to delete the last column and I'll set to null vector. So it will be removed, right? 3 and 6 will be removed. Okay. Then another thing, the third row of matrix A is deleted, right? Now to restore the third row, I mean, if it is just the 3 cross 3 matrix, then you can even write your whole array like this: A equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. But you can imagine if my array is 50 cross 50 or something like that, then it is not possible for you to write the whole array again. So what you can do is you can restore it like this. Suppose A equals to, I'm saying that A of my very first row, all the columns, it will remain same. Second row, all the columns will remain same. But for the third one, which one has been deleted, I'll make it like this. So only single row or a single column that you need to add, right? Are you getting what I'm saying is, suppose if you have deleted your third row, all the columns equals to this. This is what you have done. Now I want to restore it. So what I can write is A is equals to, then square bracket, then I can write A of first row, all the columns. Okay. Then another row, that's A of second row, all the columns. Then another one, and here you can now specify what you want, the last one which has been deleted, no, the 7 and 9, that you can specify again the square bracket, and you can check your array has been restored, right? So this is what we are doing. I hope you are getting. All right?
Yeah, ma'am.
Okay, great. Then dimensions. So how you can check if any of the image is there, right? Once we'll read the image, I'll show you everything that how to read the image. First we are dealing with matrix and vectors only, but from the very next lab we will read the whole image, then we'll check the size and we'll do the enhancement and so and so. So for that, first thing is I need to know the size of my image. So image is represented in the form of what? Matrix only, right? So you can check here the size with the function size only, size of it. So it will show you 3 and 3. First one is row, second one is column, right? And you can even take this into another variable like this, m and n. This is what you are giving equals to size of A. So in M, you have rows, in A, you have columns. Because ultimately what I'll do is I'll take the for loops and all, right? I'll deal with each and every pixel into the image, fine. So wherever I'll be having my for loop, because I need to start from the very first of the pixel, then I need to stop somewhere. So to stop where my number of rows will get over or my number of columns will get over. So at that time in the index, I want that I and j, that what you can understand in that form. So that is my m and n. So in m and n, always I'll read the size of my image. Okay, are you getting? Fine. So this is what they say, right? Then the continuation. In the MATLAB special characters, you have seen this 3 dot. This 3 dot is nothing but it's known as ellipsis. And for this ellipsis, it is saying that this is what the continuation, and this we are using to improve the user's readability. You can simply say nothing else, right? If suppose I'm writing here a is equals to 1, 2, 3. I'll check my connection in between. Yeah. Right? Then 4, 5, 6, then 7, 8, 9, and so. Right? So here user won't get from where there will be a new line. I really don't know that. So the same thing for the user's readability. To improve that, I can write like this: 1, 2, 3, semicolon, dot, dot, dot. It means that in the next line, whatever is written, it is continuous only. Then I can write 4, 5, 6, semicolon, then continuation, 3 dots, then 7, 8, 9, and then I'll take it over. So now user can understand it will be in the form of 1, 2, 3, 4, 5, 6, 7, 8, 9. This will also create the same thing. Nothing is new in that. But I hope you are getting what is this 3 dots for. So here user don't know from where the new row will be there. But here if you write like this, then user may get to know. So the same example like given here, suppose I'm having this b is equal to value, right? But I'm writing here that value with this dot, dot, dot. Otherwise you can write in a single line. So that is fine. But to improve the user's readability, you can write like this. Again dot, dot, dot. So user can get to know, okay, the very first, suppose this one. This is what the location, where I'll get the answer for 4 by 5. Then the second, here I'll get the answer that is for this. The third, I'll get the answer for this. Now in another row, a very first column is about 1 divided by x raised to 2. Then it's 0. Then it is something like this. So just to show you that we are using this, nothing else. Okay. So first I need to define the variable for x, right? I'll define the variable x is suppose 5, and then I'll write everything again. Right? Then you will have the value of b. So is it clear?
Yes, ma'am, it's clear.
Right. Very good. Fine. then you already know what is transposing a matrix. How to transpose it. Suppose this is my A, and I wish to transpose it. I just need to write dash here, a single quote. That's it. So whatever is my row, that will become my column now. Whatever is my row, that will be column now. Right? Very easy to understand, right? Okay. Then we have seen already what is the concatenation. So you can see here, this is what my A is, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what will be my matrix B? B equals to, first I'm giving whatever is my A, that would be there as my first column, or you can say like this. So very first I'm having my matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for the second one I'm having 10 into it. Then semicolon means you are moving to the new line. Then you are giving minus it, and then at the fourth side you are specifying another matrix. So it is something like that. If I'm writing B equals to, then I need to do square bracket like this. Then I can write A. Here I can write 10 into A. Semicolon. Here I'll write minus 8. And here I'm specifying some value like this. Okay? This is what I'm doing. Yes? Somebody is asking. Yes? Any question? Hopefully not. Okay. So this is what my A, right? This is my 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm having 10 into A. So that is 10, 20, 30, 40, 50, 60, and so. After that, I'm having minus A, means minus 1, minus 2, minus 3, and so on. And then I'm having this array. So this is what the concatenation of the array, right? So my B will be actually the combination of 4 different, you can say the matrix. Fine. Are you getting?
Yes, ma'am.
Yes. Okay. Fine. Then here we have the matrix generator functions, right? Built-in functions that what we are using. We have seen some of the functions in our session, like zeros and ones and random and so, right? If it would be the I means you will have one on your main diagonal. So if I'm writing that C equals to I of 5 cross 4, suppose, or 5 cross 3, something like this. So you can understand onto your main diagonal only you will have the value 1. If you are giving some value like this, suppose that is 3. So it will take 3 cross 3 and it will generate this diagonal over here. That value would be 1, other values would be 0. If I'll write like this, ones of something, 5 cross 6 or this, then I'll be having all the values 1. If I'll have zeros of 2 cross 3, suppose, so all the values would be 0. But if I'll have I, means main diagonal value, that should be what? It should be 1. Same way, if you wish to fetch any diagonal value from any of the matrix, suppose this is my A, and I wish to fetch the value 1, 5, 9. So what I need to write? Diaj diagonal of A. So it will show me the value this 1, 5, and 9. Okay? Fine. Random, that you already know, right? It will randomly generate any values between 0 to 1. Now here, suppose I'm creating that ones of and some value like 3 rows and 1 column. So I'll be having 3 different rows and 1 column. Either you can use it or you can create it via the built-in function, or you can make it as the manual entry. Both is possible. Suppose I'm creating here B is equals to and then I'm giving the value like 1 semicolon. Semicolon means on the new line, right? So 1 semicolon 1 semicolon 1, something like this. So it will create 1 1 1. Same way I can create b equals to 1, and I'll create here 3. So 3 rows, 1 column. So that will also be created like this only, right? There is no change in that. Okay, fine. Then you can have this I of 3. So I said, no, it will create 3 cross 3 and mean diagonal would be 1. Then we can create all zeros with 2 rows and 3 columns. So it will create like that. Then you can even concatenate it. Suppose you are first specifying C equals to this. So 1, 2, 3 and 4. So it is 1, 2, 3 and 4, because that you are specifying into your matrix B. So first is C and second one is zeros of 2, means this. Then after semicolon means on the new line you are having ones of 2. So 1 1 1 1. Then I of 2. So it will create I of 2. Right? So this way you can concatenate any matrix. Are you getting?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Please try this, huh? Please
Yes,
try
ma'am.
this. Just don't watch it. Try it on the octave. Okay? Together you can try it. With me. Fine. Then these are the special matrix. These are the special matrix. So here you can try this. I mean, or you can search about it and you will let me know what it is. Right? So one of this I'm saying that is magic. If I'll write here magic of 4, suppose, then it will create some matrix. Now what is the magic here? Can anybody tell me this? What is the magic here is? Yes.
M4 into 4 matrix of random numbers.
Yeah, 4 cross 4 matrix they are generating. Okay, but what is the special thing here is? You can check the summation of your rows and summation of your columns. You can check it out. Summation of row and summation of your column.
Both are same, ma'am.
Yes, right. You can even check for the diagonal. Just check and let me know what is the answer.
34, ma'am.
Right? So are you getting what is the main thing and what is the special thing about this? Right?
Yes, ma'am.
Okay, great. Great. Now here, you can check for the other metrics also. That is your homework, right? You can take a click and the next time I'll ask you, right, about this. Okay. Now we'll again move on to the array operations and linear equations and all. You already know what we can do with the matrix, right? Matrix arithmetic, you have already performed. Okay. So what you will do is just create two matrices, A and B, right? And perform A into B, okay? Then what else you will do is A raised to 2, something like this. Please do this and let me know. Please do this and let me know. you can take the size of A and B different. Okay, first you will take the size of A and B, that would be different. And here for this A raised to 2, for that also you can take the size of A like a 3 cross 2 or something like this. It should not exactly, I mean 3 cross 3 or 5 cross 5 or something like this first time. First you will take the row and column size differently, and then you can try with this first and let me know what is possible and what is not. Okay, is this clear?
Ma'am. Hello, ma'am.
Fine. So it is done, right? So first, suppose I have taken A is equals to 1, 2, 3, 4, 5, 6. This is what I have taken. So you can check here, I'm having the number of rows 2 and the columns 3. Okay. Now, uh, if I'll take B here, that is 1, 2, 3, 4. Okay. And now if I'll try A into B, then what will happen? It will show you an error. Why? Because we already know what is the matrix rule, matrix multiplication rule, right? Same way, okay, we will skip that A into B. But what about A into A? That will also give you an error. What about A raised to 2? That will also give you an error, because ultimately this A raised to 2 means A into A. If A raised to 3, it means A into A, right? So they all are showing you an error. But if the same thing you are doing in element wise multiplication, then here also the problem, what matrix dimension must agree. So actually what is the problem here is, here can anybody tell me what is the problem? A into A dot into B. What is the problem in that? Because here your number of columns and rows should be at least same. Why? Because it will do element wise multiplication. So this one will be multiplied by this 3 with this 4, this 2 with this 2, this 5 with this 4. But what about this 3 and 6? So at least you can take the same dimension. Suppose for the A it is fine. For B equals to, I'm taking, okay. Now you can check for A and B, though here you can still cannot do this A into B, right? Still you cannot do that A raised to 2. That is still not possible, right? But you can now A into star B. That is now possible. Okay. Same way here, this a raised to 2 is not possible. It will show you an error. So what you can do? You can do a dot raised to 2. That is still possible. Why? Because it will just do the squaring of your element by element. So that is fine. I hope you are getting, yes. And here still you can do this a into a. No, why? Because again it will apply the matrix multiplication, but you can do a dot star a. That you can do. Fine. So this is what I was asking about. Fine. This is what I've already explained, element wise. Right? The same thing. What I've explained. Okay. Fine. So any doubt in this? Hopefully not.
No, ma'am.
Okay. Great. Fine. Now we are solving the linear equations. So here you can check this. X plus 2y plus 3z equals to 1. 4x plus 5y equals to 1. 7x plus 8y equals to 1. So if you are simply taking this coefficient matrix A, right, so it would be like 1, 2, 3, 4, 5, 6, 7, 8, and 0. Here is the printing mistake, right? It's 1, 2, 3, 4, 5, 6, 7, 8, 0. And for your vector B, means for this answer equals to, this is your 1, 1, 1. Now you are generally writing Ax equals to B. And if you want to find the value of x, it is something like what? A inverse B, because this will come over here. So this is your A inverse into B. So this A inverse B, how you can calculate? So the first one is to use the matrix with inverse INV. So what I can do, this is what my A, that the coefficient, then B equals to, you are giving some value, this 1, 1, 1, and so, okay. And now you are calculating for this x equals to inverse of A, because I already said no how to do the inverse. For that we are having a INV function. So inverse of A into B, that will give you the value of x. Fine. So this is what we are getting. And the second option, what you can do is, do you remember that shift, sorry, right division and left division? Do you remember that? Yes. So what I can apply here is, I can apply the left division here, right? It is ultimately what? Inverse of A into B. Fine. Ultimately it is inverse of A into B. So that what we want, right? So I can simply do, because the value of A and B are same, now I can give x equals to A, this left division, and B. So I'll get the same answer. Fine, okay. Yes. So please try this. Do this by your own, both the methods. So is it done? Everyone? Okay, great. Now you already know what is matrix inverse, right? If I wish to inverse this, I just need to write inv function, inv of A. That will do the inverse of matrix. If suppose this is my A, 1, 2, 3, 4, 5, 6, 7, 8, 0. And if I'll write inverse of A, I'll get such kind of answer, right? Which is in the mathematical term very similar to this. Then if you wish to find determinant of A, how to find in maths, that you know. But here if you wish to find the determinant by this function, you just need to write det and you will get the answer. Fine. Then you are having these functions. One is for determinant, one diagonal, that what we have seen. That inv, that is for matrix inverse. Now you have to find this three function. eig, that is eigenvalues and eigenvectors. Norm, that is for matrix and vector norms. And rank is about a linearly independent row or columns. So this three is again for homework. You search about these functions and let me know where we are using it and how we can use it. Okay. Fine. Now we'll move on to the next one. This M file scripts and functions and all that we will do in our theory session. So we are skipping this for now. How to take input and all. And for the output, you can understand these are the functions. Display is the function disp, very similar to use, and here you can use even f print or s printf, right? For the appearance of the output. Whatever you will write in disp, that will be displayed. Now we will see control flow and operators. Yeah, one more thing I forgot to tell you. See, here if you will do this magic of 2 na, then you won't get the exact answer. Like here 4 plus 1 is 5 and 3 plus 1 is 4. So you can check here in help and this magic. So you can check that this magic of n is n by n matrix, which is constructed from the integers, and it will give you the row, column, and diagonal sums equal. And it is valid for except n equals to 2. So when you are giving magic of 2 means 2 cross 2, then it is showing you not the correct answer, right? So it is valid only greater for the greater than 0 but except n equals to 2, right? You can try with this magic of 3, you are getting the same answer, 8 plus 1 and the 6, then 4 plus 3, 7 plus 8, 15, then 8 plus 5 plus 2, and so it is I mean magic of 3, 4, 5, 6, 7, 8, 9, everything will work perfectly only except n equals to 2. Okay, fine. Are you getting? This was the topic which I missed to tell you.
Demo.
Then here in this control structure, you already know, I mean, how to control the flow of your program via if and else, right? So MATLAB is even has a 4 control flow structure. One is if statement, for loop, while loop, and switch statement, right? Via this 4 you can control. Now here, how you can write this? You can check here. You are writing here if, right? You are writing here if. And after this, you compulsory need to write end. Same way. Okay, so such kind of structure you have seen in the other programming language also. Where can you tell me this? Yes, in Unix or somewhere, maybe you have seen this if and then you are writing at the last end. Yes, in Linux. Okay. Anywhere else? Fine. Okay. Okay, fine. So here, if suppose you are having if and else both, so you can write if, then else, and at the last end. Then if it is else if, more options are there. So if, then else if, else if, else if, so many times you can write, then else, and at the last it's end, right? So the simplest form, if you can discuss here, is if, then any of the expression you are writing here, then the statements according to it, and finally you are writing end. So a very familiar formula, that is for the quadratic. B square minus 4ac, you are finding the roots and all, right? So in one of the variable you are finding this b square minus 4ac for some value of b, a and c. Now you are checking if this DISCR, this value is less than 0, then it will print. It will print something on your screen. For that you are having functions like display, you are having function like sprintf, then fprintf. So these few are the functions via which you can write onto your screen. Okay. So please try this and let me know what output you are getting for some value of B, A, and C. Please try this. So is it done? Are
Done,
you
ma'am.
checking out? Yes. Okay. So suppose here I'll write this value for the A, B, and C. So first I'll give the value of B. That is 2, suppose, for A equals to 4, for C equals to 10, and something like this. Okay, and now I'll paste this B square minus 4AC. Then I'll check for this value. Okay, and I'll display the roots are imaginary, and I'll write n. Fine. So I'll get the same message that discriminant is negative and roots are imaginary. Okay, because my b square minus 4ac is actually less than 0. Fine. Then I'll change the value. B equals to, suppose, 10, A equals to 2, C equals to 3, something like this. And then we will try for this again. But here we are having the value for if and else both. Okay. So if I'm printing this, for the else, I'll print this. Fine. So what they are saying is roots are real but may be repeated, because here my value of DISCR, it's greater than 0. So it will go to this else part. Right? It will go to else part and it will print this. Then you can try for this third one. Please try this, where you are having this else if. There is no space between this else and if. Okay? They are continuous. Say yes or no. Will you try this third one?
Ma'am, show the PPT once, the
Yes,
PDF.
I'm showing you. Is it done? Only one is saying yes. What about the others? Have you checked this?
Almost, ma'am.
Give the coding value for this B, A, and C, right? You can give the value in such a way that, the value of this A and C accordingly, so this will become 0, right? So this will be printed. Fine. Here you can check this else if has no space between else and if, it's a single word. No semicolon is needed at the end of the lines containing if, else, and end. So wherever you are writing this, no need to put any semicolon. Indentation of if block is not required. After if, you can even write the statement with just a blank space. That is also okay. But it will, we are facilitating the reading, and that is why we are always keeping this indentation, right? And here at the last end statement is required. So is it clear? So that's all for today. We'll see there's operators and everything that what we have seen, but there's loop and all that we will see in our theory session. Okay, this is what we are going to do in theory. So that's all for today. You can write your enrollment numbers and you may leave. Please, you can write your enrollment numbers, please. Abdul Karim Dura, Abisa, Fatima, Evan, Muhammad Asif Raja, Ranim, Sachit, Suman. If you have not written your number, you can write your numbers and you may leave. See, no numbers will be considered into the WhatsApp or the Telegram group. I'm giving you the last reminder. Please write your numbers here and you may leave the meet.